Hello, in this video I'll be going over the code for our ohm and capacitor meter circuit. Right here we have a little overview of the code. This includes the course name, the circuit name, the purpose, how it works. This one is just a little bit of how we put the code together, the authors, and the date. The first two lines just include the library for the LCD and the IR. Right here we have the pins for the LCD. In this line, we have the pin for the IR receiver. Right here, we have the variables for the resistors. R1 is the unknown resistance, R2 is the known resistance. These are the pins for the known resistance, which is pin 4, pin 3, pin 2, and pin 16. Pin 16 is also analog pin 2. Pin 4 has a 1K resistor. Pin 3 is a 10K. Pin 2 is a 100K, and pin 16 is a 1 megohm. Here are the units. Right here we have our capacitor variables. Analog pin A0 is used to read the capacitor voltage. Charge pin 5 is our charging resistor, which is a 2 megohm right here. And the discharge pin is pin 6. It's a 220 ohm. It's not really big. Right here is the start time, which we denote as tau. It just calculates our time. And then right here we have that capacitor could be a decimal. This is our setup. Right here we initialize the LCD. And we add a line that says to choose a meter. For ohm meter, we press up on the button for the IR remote, and then down for the capacitor meter. We leave this message on the LCD for 3 seconds. Right here we check if we have a valid IR signal. This right here is just if we press the up button on the remote, we get to the resistor meter. The resistor meter repeats until the user presses the restart button on the Arduino. Same goes for the capacitor. This is if we press the down button on the remote, will take us to the capacitor meter. This is the code for the resistor meter. We clear the screen and tell the user to pick 1, 2, or 3. 1, 2, 3, or 4, which will take us to the resistors, the non-resistor values. And then all resistor values are set to inputs. Right here is a placeholder for the resistor values, since no resistor values are selected yet. Once one is selected, let's say you press the first button 1, that will take you to the 1000 k ohm. Button 2 will take you to the 10,000 k ohm. Button 3 takes you to the 100 k ohm. And then the button 4 takes you to the 1 megohm. Then we wait for the signal, no valid one is received. All resistor values are set to inputs until one is selected. We use the selected one to calculate the unknown resistor, which is R1. Then once the R1 is selected, we do the calculations, and it's R1 and R2 are both printed. If the unknown resistance value is bigger than the known resistance value, we tell the user to increase the scale. And if not, it just prints out the resistance values by itself. And this is the code for the capacitor meter. We set the charge pin to output or to ground so that the capacitor is not charging. And then once the capacitor starts charging, it's a continuous loop. Using the time, we calculate capacitor by dividing time by the resistor value, which is 2 megohm. And then the units are in microfarads. If the capacitor value is less than 1 microfarad, it's converted to nanofarads. Right here we print the capacitor and its value. The capacitor is then discharged until it reaches 0 by setting the charging resistor to ground. And right here it keeps on discharging until it's fully discharged, and then delay 2 seconds, and restart the code. Thank you.